If you'd like, you can go ahead and start the live stream. Hello, everyone. This is John Clute, K7SYS, and I am your amateur radio moderator for today's ARIS, Amateur Radio on the International Space Station Contact. I'm speaking to you from my home in Sandpoint, Idaho. What makes this contact a little different from the usual ARIS contact is everyone involved in this contact will be speaking to you from their home as we all work with COVID-19 restrictions. Through the help of amateur radio volunteers and the crew on the ISS, we hope to soon establish an amateur radio contact with the International Space Station as it flies more than 200 miles above the Earth over Portland, Oregon. This contact will be performed using the Amateur Radio Telebridge Network, a worldwide network of amateur radio ground stations that enable students to contact the ISS. We are joined today by Heather Randall from JFK High School in Denver, Colorado, as well as Norm Thorne, K6UU, the ARIS technical mentor who helped set up this call. We have a short video introducing JFK High School. Let's all watch that video.
JFK is a comprehensive neighborhood high school in Southwest Denver that empowers students to focus on their post-secondary goals. The school's distinguished whole child approach closes traditional equity gaps to provide all students the opportunity to rise to JFK's future vision, which states, "As commanders, we are advocates of our passions, challengers of inequity, and champions of change. We find pride, professionalism, respect, inclusion, dedication, and excellence in shaping a more inclusive global community and taking command of our role within that world." JFK empowers the whole child through best-in-class programming across the academic, social-emotional, and post-secondary domains. JFK pushes students to see beyond their known scope of Southwest Denver and to become champions of change for themselves and their loved ones. The whole child strategies provide a solid foundation to take command of their future. This past year, the high school engineering program at John F. Kennedy High School was awarded the Jfk Space Lab presented by Ration. Our school was one of 5 across the country to receive a first-of-its-kind Jfk Space Lab presented by Raytheon to commemorate the 50th anniversary of the first moon landing and President Kennedy's vision. Our students are exploring the ISS above cameras and learning about ham radios, as well as the types of careers in engineering communications. As a highlight of this partnership, JFK learned about the ARIS program and immediately sought to incorporate this initiative into our learning experience. We even invited our neighboring middle school, Bear Valley International Middle School, to share this once-in-a-lifetime opportunity with us. A select handful of high schoolers and middle schoolers will soon be able to share that they spoke to astronauts on the International Space Station. We hope this experience provides an opportunity for the JFK community to get a look into the legacy of its school's namesake.
Well, thank you for introducing your students and sharing with us something about JFK High School. ARIS is an international program supported by amateur radio operators from around the world. Some member organizations of ARIS are the American Radio Relay League, the Worldwide AMSAT, Radio Amateur Satellite Corporation affiliates, as well as space agencies including the Canadian Space Agency, the European Space Agency, the Japanese Space Agency, NASA, the National Aeronautics and Space Administration, and the Russian Space Agency. The amateur radio ground station that will establish contact with the ISS is NA7V, located near Portland, Oregon, and operated by Dave Nico Payne. Nico, please tell us a little bit about your station and how you will handle today's contact with the ISS.
Good morning. This is Nico at station NA7V. The radios and antennas are computer controlled here, and we'll be tracking the spacecraft using orbital software. This orbital software controls both the antenna positions to keep them pointed at the spacecraft, as well as the Doppler shift that affects the uplink and downlink frequencies. I will start calling the ISS just before the spacecraft reaches our horizon. They won't hear me at first, but we start early just to get the closest or the fastest contact possible. So you'll hear me calling, you won't hear an answer for a while. The spacecraft is currently out over the Pacific Ocean, right about over Japan actually right now. And we hope to make contact while it is still over the Pacific Ocean, just approaching us in Portland. When I begin calling, you'll hear some background radio noise. This is normal. And my ground station is more powerful than the radios on the spacecraft, so they'll hear us first before we hear their return call. Anyway, that's about it. Back to you, John.
All right, very good, Nico, and thank you for sharing with us how your station will work and a little bit of what we can expect when the ISS is approaching you. We have about 12 minutes to contact time. Our contact today is with astronaut Mike Hopkins, KF5LJG, who will be using the ISS call sign NA1SS. The American Radio Relay League has provided us with a short video that tells us a little bit more about an ARIS contact and how it all happens from the perspective of those of us on the ground. Let's watch that video.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code, and then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope, orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, We can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
NA1SS, NA1SS.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ARIS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
I think that's a really good explanation to us of what this contact looks like from the ground side. But obviously there's two sides to this contact. Astronaut Tim Peake, KG5 BVI, recorded a short video to show us what a contact looks like from the ISS side of things. Let's go ahead and watch this video as well.
NA1SS, this is N2SJ, over.
NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now this is the equipment here in the Columbus laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
Very, very interesting. Did you all notice that the radio that Tim Peake was using just seems to be floating in the microgravity of the International Space Station. It's not really attached to anything. I always find that fascinating. The ISS is presently approaching Alaska, and I have about a little over 4 minutes until the time of the contact. As astronaut Tim Peake noted, they are traveling at about in the range of 18,000 miles per hour and at an altitude of 200 miles. If we do the math and work that out, we'll discover that an ARIS contact lasts about 10 minutes. The 2-meter band that we use for the amateur band that we use for these contacts is a line of sight band, which means the ground station NA1 and NA7V must be able to see the ISS NA1SS for the contact to occur. With 10 minutes, we always try to get just as many questions in as possible, and it's quite conceivable that the ISS may disappear before we get to the end of the question list, and that is a very normal thing to happen. We think it's more important to have students asking questions than to have what we call the 73 round, the goodbye round at the end of the contact. So you can expect questions to be continued to be answered. The ARIS program is presently celebrating its 20th anniversary, and we have made well over 1,000 contact with schools around the world in the course of this program. It is the longest-running continuous experiment on the International Space Station that began very, very shortly after the International Space Station was permanently occupied. In response to COVID-19, the ARIS program, just like you, has changed our approach. With you no longer able to go to school as usual, we are using distance learning tools to bring the astronauts to you as you shelter in place or your homes or meet under different conditions at school. We all need to be just as quiet as possible when not speaking, so please remember that some of us are home. But because we are at home, if the dog barks or little sister unexpectedly cries, or as we heard on one contact, a rooster is crowing in the background, these are just the sounds of home. Remember, what we are doing on the ISS is an experiment, and we can never quite know how the results will turn out until the experiment is finished. It's very important for the students to say over, as this is the cue to the ground station to go from transmit to receive, and it is the cue to the astronaut that it's time for a question answer. We are now about 2 minutes out, and the ISS is now well over just south of Alaska, over the Pacific Ocean, approaching the west coast of the United States. It is at -6 degrees of elevation. This is always one of the more difficult parts of a contact, as we all wish it would happen a little quicker, but there's no way to speed the ISS up or make it go faster. So all we can really do is be patient as it approaches our location. So we continue to wait. We're now to about 4.5 degrees below the horizon of NA7V in Portland. And we are, as Nico, the operator, had said, we usually like to crawl before the ISS was completely over the horizon because we want to make sure that we have just the longest contact time possible. I now show the ISS at -3 degrees, and I'm going to turn it back over to you, Nico. It's all yours. Take it away, and good luck.
All right, thank you. November Alpha 1 Sierra Sierra. November Alpha 1 Sierra Sierra from.
Nico, your audio is awfully low.
Say again, John. November Alpha 1 Sierra Sierra. November Alpha 1 Sierra Sierra. From November Alpha 7 Victor, scheduled contact. November Alpha 1 Sierra Sierra. From November Alpha 7 Victor for scheduled school contact. November Alpha 1 Sierra Sierra from November Alpha 7 Victor for scheduled contact. Okay, I have rough copy on you. Come again.
And November Alpha 7 Victor, this is November Alpha 1 Sierra Sierra. I'm reading you loud and clear. How many? Over.
All right, reading you clearly. Are you ready for questions?
I am ready for questions. Over.
Okay, school, let's go.
This question for Candace. How do you find time to do personal hygiene when you are so busy doing research and experiments? Over.
Hey, Candace, thanks for the question, but first I want to say hi to the whole JFK High School. In terms of hygiene, we actually get time after we wake up and time before we go to bed to do hygiene. And one of the rules we always have up here is in order for us to do the science, the research, the experiments, we need to take care of ourselves. And that means eating, drinking, exercise, and also the personal hygiene. Over.
Hi, this is Jenny. Does a carbonated beverage, once open on the ISS, stay carbonated for the same amount of time as it does on Earth? Over.
That's an interesting question, Jenny, and I don't know the answer to that. The pressure inside the space station is the same as what it is down on Earth. So theoretically, I don't think it would necessarily be any different. On the other hand, fluids behave much differently up here, and so we can't just open a beverage like that because it would go everywhere. Over.
Hi, this is Clarissa. We recently learned that each astronaut eagerly awaits a special package from Earth. What is it that you look forward to most? Over.
Hey, Nicole, that's a great question because we just had a couple of supply vehicles that arrived this week with some of those special packages. And you always look forward to having something from your family, but one of the things we all are eagerly awaiting is some fresh food, including fresh fruit. In fact, right before I started this, I had a little bit of an orange, and it was fantastic. Over.
Hi, this is Nicole. Are there any environmental sensors like weather, fire, soil, ocean that you monitor or track as part of your daily work? Over.
In general, for the astronauts, we're not doing that on a daily basis. However, when there are natural disasters like floods or fires, they may ask us to take pictures of it as we go over, and that's how we would monitor it. Over.
Hi, this is Emily. What is the most physically demanding task you have to do in space? Over.
Hey, Emily, one of the most physically demanding things is just the normal exercise that we do. It is good exercise. It helps prepare you for when you come back home to Earth. But then also spacewalks are pretty demanding. And so we just did a couple of those a couple weeks ago. Over.
Hi, this is Diego. What was going through your head when you first found out that you were chosen for the mission to ISS? Over.
Hey, Diego, that's a great question as well. It's when you first get selected to be an astronaut, you're pretty excited about that, and you think it doesn't get any better. But when they actually tell you they're going to send you into space, it's kind of amazing, because you're like, wow, they really intend to send me up there, and so it's just it's an unbelievable feeling that's hard to believe. Over.
Oh, hey, this is Jorge. How comfortable are the new spacesuits, and what is your new favorite feature of these spacesuits? Over.
Anyway, the spacesuits, when we wear them, like with the SpaceX spacesuit, it's pretty comfortable when you're just walking around in it and you're sitting in the seat. When it becomes less comfortable is when it actually has to do its job, and that's to keep you alive if we should have a depress event, and then it kind of blows up and it gets very stiff, and it's not easy to move around in. But that is my favorite feature of that spacesuit, is that if anything goes wrong during the launch or the landing, that's going to help keep us alive. Over.
Hi, this is John Yan. Do you have to monitor and/or ration your water while in space? Over.
Hey, Johnny Ann, no, we do not. In fact, most of our water comes from us. It comes from our urine, and we recycle that water. And so I think we're in the 80-90% somewhere around there that we're able to recycle. And so we don't have a ration, and we drink and use it for our food as much, and hygiene as much as we need to. Over.
Hi, this is Aaron. Have you ever performed a medical procedure or administered first aid to another astronaut? Over.
Hey, Aaron, fortunately not, but that's a great question, because we actually get trained as medical officers, even if you don't have that formal training as part of your background. I'm actually not one of those medical officers on board, but the three crewmates I came up with, Victor, Shannon, and Suichi, all are trained as medical officers. Over.
Hi, this is Bo. How do you relieve stress when on the space station? Over.
Hey, Bo, one of the things we always do when we have a little bit of free time is it's just to get in touch with your family. And so that's one of the things I like to do. And then the other great thing is, I'm staying in SpaceX Crew Dragon Resilience, and it has windows. And so when I'm in my crew quarters and I'm talking to my family, I actually get to not only relieve stress by talking to them, but then I'm also looking down at the world as it goes by, and that's a great feeling as well. Over.
Hi, this is Jared. When you're sleeping in your bag, do you feel like you are floating, or do you anchor yourself down? Is this comfortable? Over.
Yeah, Jared, sleeping is a little bit different up here. If you've had a long day and you remember and you're really tired and you lay down, it feels really good to just kind of get the load off your feet. Well, up here, we never have a load on our feet, so you never get that kind of same sensation. So it does always feel like you're floating a little bit, even though you kind of strap yourself down in your sleeping bag. But is it comfortable? Yeah, it's pretty comfortable. Not too bad at all. Over.
Hi, this is Anicia. When in space, do you take special precautions regarding safety during a spacewalk? Over.
Yes, that's the most important thing we do when we go out on a spacewalk. And so we always have to be attached by 2 points. And so when we first go out the door, we put down what we call a safety tether. And that goes with it, the big reel that as we're moving around station, it reels out this long cable. And then the other point of contact is always our hands, or once we get to a work site, we can put down another safety tether or waist tether to make sure we have those 2 points of contact always with station. Over.
Hi, this is Gianna. Did your training accurately prepare you for the stresses of launch? Over.
Gianna, that's a great question. Launch was absolutely unbelievable, and yes, our training did a great job of getting us ready for that. But we can't simulate what it's actually like, the G loads and and just the vibrations and all that. It's really hard to simulate that, so you just do sim practice again and again, and so the procedures you're pretty familiar with, but then the actual feeling is something that you can only experience on the launch itself. Over.
This is Jenny reading a question for Candace again. What is your preferred form of exercise on Earth, and is this something you can continue to do on the ISS? Over.
Yeah, so my preferred exercise on Earth is basically lifting weights and running, and yes, I can do both of those on ISS. We do have a treadmill, and we have a weightlifting device that uses the vacuum, basically a cylinder that we take the vacuum and we can pull against that vacuum, and it works really well. We can do all the normal lifts like squats and deadlifts and bench press, etc. Over.
This is Jenny again. How long did it take you to get used to the bathroom facilities and procedures on the ISS? What was the hardest part? Over.
Jenny, that's a funny question. So, one of the things about microgravity in space is the simple things become hard, and that is definitely one of them. It can always be a little bit messier up here in the microgravity environment. Do you get used to it? Yes. But I think that is one of the things that I'm not going to miss whenever I have to come back to Earth, and that's having to use the toilet facility up here. Over.
This is Clarissa again. If there was one plant you could grow in the International Space Station, what would it be and why? Over.
Clarissa, what a wonderful question. We actually have a lot of plants growing on station right now. We've got peas, we've got basil, we've got pak choy, we've got mustard, and so, if I had my choice, anything that's edible would be my first choice, but then I'd also love to be able to grow a flower while I was up here and take it home to my wife afterwards. Over.
This is Nicole again. Have you ever had a malfunction with your spacesuit? What did you do? Over.
Very fortunate I've never had a malfunction with our spacesuits, but today we are actually doing a leak check on our spacesuits for the two that are going to go on spacewalks this weekend, and we didn't pass one of the leak checks, so we did have to just troubleshoot, and one of the things that means is you just take piece by piece off and just verify that there's nothing that's stuck in between the seals or that's nothing that's broken. Over.
Hi, this is Emily again. How has COVID-19 changed your space travel? Over.
Hey, probably the biggest impact COVID-19 had on our space travel was the before and the after. So before launch, we really had to make some adjustments in how we train, and also...
Okay, we've lost the space station over the horizon.
JFK would like to thank the ISS on the count of three, commanders. 1, 2, 3. Thank you.
Thank you.
All right. Well, thank you, everyone, for a most wonderful contact. We've all been part of a distance learning activities featuring students from JFK High School speaking with Mike Hopkins on the International Space Station. On behalf of all the ARIS International volunteer teams, sponsors, and space agencies, this is John, amateur radio operator K7SYS, sending my greetings to all of you in traditional amateur terms, 73s, which means best wishes. At this point, we may conclude the